for the final time, we have one of these webinars. So it's sad that I'm not going to spend an hour of my day for the next few weeks doing this. And the attendee numbers are going up, which everyone that has attended all of these will know that I say on every call. Henry, how you doing while we wait for everyone to join?
Very well, very well. It's a nice warm evening in the UK where I am.
It is nice and warm, isn't it? I suspect that anyone that's attending this one on a Monday probably has come to all of the sessions so far. If not, welcome. But anyone that's attended them all will know that we'll just wait a couple of minutes just to start, just to make sure that anyone that is attending doesn't miss anything. We'll probably start at about 2 minutes past, so give it one more minute and then we'll start. Hope everyone's doing well. If you want to, as we're going along, have any kind of conversations, please use the chat, use the all attendees function, and everyone will be able to see what you say. We will probably have about 20 minutes of questions at the end. There's been 6 or 7 that have been sent across to us directly already, so we'll answer them, and thank you very much for the people that sent them across. But if you want to put any questions you got in at the end, I've been on all but one of the sessions, so if for any reason you have questions that maybe you didn't ask in any of the previous sessions, so anything from front end to back end to data to DevOps, or anything from this session, please do put them in Q&A and we can't answer them. If for any reason you're shy and you don't want to do that, connect with me or Henry via LinkedIn or contact us. Henry, what's your email address?
Henry@hackajob.co.
Oh, you've got one of the originals. .co, and then mine is Darren@hackajob.co. So contact us there. Give it one more minute.
Yeah, I snuck in just before the company began to use first name.
Yeah, I was gonna. I've got 2. I've got a first name dot last name, and I've got a first name. I don't like first name dot last name because people spell my second name wrong. So it's never very helpful when people are reaching out to me when they use that one. Cool. Let's begin then. So from an agenda perspective, what we'll be going through today is 3 different sections. I wanted to, at the end of our time together, chuck a couple ones in there which are a little bit of coverage. So we'll be going through the final kind of modern software engineering languages, so Scala, Kotlin, Go. We'll be touching on modern testing concepts. So I believe in the session on Wednesday last week, we went through testing at quite a high level. So we'll be going through that, and then we'll be going through mobile development. And then at the end, like I say, I purposely left quite a lot of time to have any questions. So if you've got questions on any of the topics we've gone through during these, please shove them in. Henry, I believe you've got the first couple of slides.
Yeah, and for everyone who's not really met me before, as this is my sort of first appearance in this sort of training sessions, I'm one of the talent success leads at hackajob. Work with our candidate base on making sure they are fully prepared for their interview processes and have all the information they need to make sure they're making the right career moves. So yeah, kicking off with sort of what modern software engineering is. Obviously, it's a very broad subject, but it loosely refers to obviously modern advances in technology. And it says here driven by obviously the adoption of DevOps and Agile, but I think also very much a sort of a cultural sort of drive from companies, startups, and obviously the need of the issue or problem they're trying to solve with technology, as well as obviously the advances in cloud computing and architectural structures. So we've got 3 to go over: Scala, Kotlin, and Go, which are sort of the primary ones we see in the marketplace at the moment. So Scala, first of all, it's both object-oriented and highly functional, built on the JVM. And used builds of web applications and also in data engineering, used by companies like Klarna and Monzo Bank, popular in sort of fintech space. Key frameworks are Akka, Play, and Scalatra. It supports obviously object oriented, like I said before, but it's also highly functional, so quite useful. There are a few things to look out for with Scala, both on sort of the red flag side and obviously its current framework. That's what we're going into testing obviously a little bit more detail later, but more onto the automation side. Scala has its own testing, Scala test. Additionally, it's heavily used in obviously microservices, DevOps, data and databases. And the red flags, like I mentioned, data engineers often have the Scala on their CVs or job specs or profiles even, which they might not understand how to code in it. However, obviously they may be using it as a sort of testing or to run data programs. Responsibilities, obviously fixes, monitoring tickets and support can be an issue occasionally, and being a newer language, as with Kotlin and Go, so will be a common theme. Salaries can be a little bit higher, as obviously the experience levels, there's a larger gap between people who are fully up to speed with it and people who are still learning. So possibly cross-training Java engineers is a very useful way to upskill and also reduce cost for businesses. Moving on to our next language, Kotlin. Again, object-oriented programming language, also built on the JVM. Also used to build web applications and Android applications. Google actually make Kotlin as their recommended language now for all Android development. It is the most used sort of Android programming language now. All Java frameworks work in Kotlin. It's also cross-platform. It's statically typed and very much a general purpose programming language. Used by a whole host of companies like Uber, Pinterest, Google, Amazon. Incredibly popular modern programming language. Sees a lot of use across enterprise and startup landscape. Again, we've got a few things to look out for with Kotlin. The sort of mobile engineering side. With Kotlin, obviously, if you want someone to be sort of cross-functional for both sort of for native apps or mobile for iOS and Android, can be obviously a little bit of nuance there. Again, responsibilities, who's going to fix it, who's going to monitor tickets, and who's supporting it. You need to make sure you've got the correct teams around to be able to manage it. And again, like I said before, being a new language, salaries can be higher. Cross-training so Java engineers is a great way to get more people into the process and trained up using Kotlin. And our final sort of modern language we're looking at is Go. Both highly objected and highly functional, heavily influenced by Kotlin. It's used on large scale, highly distributed systems due to its speed. It was developed by 3 people whilst they're at Google, which was Rob Pike and Ken Thompson. It's used obviously by lots of large companies like PayPal, Dropbox, for example, also statically typed. But it's, yeah, like I said here, often used on large scale, high distributed systems. It's incredibly fast and works incredibly well. Again, there are a few flags similar to the others. You need to make sure if you're going to be programming in Go that you have the teams to be able to fix, monitor and support it. The testing package provided by Go supports package testing, which is obviously very useful. Command to automatically run these tests reduces time. But again, the last sort of red flag point here, being a new language, again, Golang standards can be higher. And again, it's very easy to cross-train Java engineers into Go, which is an incredibly useful way to reduce sort of hiring costs and headcount costs.
Yeah, and I think as we've gone through the languages, you'll see it's purposeful that there is a lot that crosses over between them. When you look at how they're kind of set up, I think the other languages that are potentially missing on here that intentionally is Clojure and also Rust. But I think the recurring theme here is that they are all quite expensive languages to hire people in. And I think that when me and JD were going through things last Tuesday, we highlighted that Java is a very widespread and utilized language. So it's often a good language to start from. There was a reason that I made sure that picture of Google and Kotlin huddled together, and then Java on its own kind of was there, because I think you're seeing a lot of candidates move from one to the other. I would say that if you look at a lot of object-oriented languages, it's very easy to cross-train across one to the other. Engineers are very inquisitive. They often do like learning new languages. It's very rare that nowadays you'll see an engineer that's been in one language their entire career. So I would always be looking at someone's acumen to learn a new language rather than just looking at what languages they learned before, because you're going to find some hidden gems doing it that way.
Yeah, absolutely. Obviously, with the Java virtual machine as well, all that basis of Java, anyone who's deployed through that is going to be able to pick these up, because they can all run through that as well.
Exactly. So talk about from a testing perspective, I think that nothing, when we look at testers, there's always the assumption that testing can be automated and fully automated, but the reality is that software testing fundamental number one is you can never automate everything. So the objective of a manual tester is simply to make sure that they are identifying any bugs or any defects that may not be able to be picked up by a framework. So the whole point of having a manual tester is that they'll be going through your website, your application, and clicking through all the buttons and see if they function like a human would expect them to. So if I'm clicking onto the basket at Amazon, does it take me through to my basket, or does it take me through to buying a mouse? So that's what a human will be able to look at. It's looking at making sure that this is working the way that I would expect it to as a human, not what a computer would expect. So that's the advantage of this, that you're identifying behaviors and problems that a human would expect. The problem is this can be very labor intensive, because you're clicking through every individual error, every individual page. It means that you need to have a human every time you're doing a click, which makes it both labor intensive and also expensive, because a lot of time, if you aren't automating as much as you possibly can, you would have a manual tester doing stuff that you need a manual test for, but also a manual tester doing stuff that you can automate. So it's about having a combination of two, and that moves us on to automation testing. So automation testing involves using tools to execute testing cases. So ones that I suspect people are very, very familiar with is stuff like Selenium, but we obviously touched on a couple of different testing frameworks in previous sessions, like NUnit for C#, JUnit for Java, PyTest for Python, etc., etc. So the objective of having a automation tester is that ultimately it saves time, saves money, and saves manpower. And also, when you have set up the framework, it can work forever. So once that testing framework is set up, you can run tests through it extensively going forward. The advantages is that it's less labor intensive, because you can have computers doing the jobs that you'd expect a human to, and it takes a lot of the monotonous tasks away, where you're executing the same test over and over again. As we all know, the more monotonous tasks you're doing, the more mistakes you're humanly going to make. So this is taking the human element out of it to make sure that mistakes aren't happening. The problem is it can only really be used on stable systems, and it's mainly used for regression testing rather than like black box or white box testing. And you get STETs. So STETs are really, really interesting. They've been around for a number of years now, but I've really only seen in the last few years people hiring software developers in test from software development in test type backgrounds. Historically, when hackajob first started, and when I first started at hackajob almost 7 years ago now, a lot of the companies we were working with, if they were looking for STETs, and one of them is a big US bank, they were often hiring Java engineers, and then they were training them in Java. And if I'm a Java engineer, some people may think, why would I move into a testing role if I'm a Java engineer? Two reasons. One, you become a specialist in an area, but secondly, it's a very highly paid area, because at that time there wasn't as many candidates out there that had that experience. So they were basically bringing in Java engineers who had an appreciation for testing, and maybe weren't ever going to be a principal Java engineer, but a really good Java engineers overall, like maybe mid-level. But then they could specialize in testing, and that could increase their salary and also increase their seniority in the business. So the objective within a software developer and test is they are as good a engineer as they are a tester. So they are finding solutions that automation wouldn't be able to find, but also if they are finding a error in the code, they're able to go in there and fix it. Again, the advantages here is that it's less labor intensive, and also there's less reliance on software engineers, because essentially an SDET can come in and fix the issues. So you're not expecting your software engineers to give the code, testers then test it, then the tester has to pass it back. Then the software engineer goes in, adjust the code, sends it back to the tester, who may say it fails again. So by having an SDET in there, the SDET can go out, fix the issue if it's a small issue, and then they can test it and then pass it on, rather than that kind of back and forth mentality that you might have if you are relying on a software engineering and an automation testing team. The disadvantages, like I said, is even to this day, SDETs are very rare to find, or in comparison to automation testers, they're rare. So therefore, they can command a sizable salary. If you're looking at the difference between an automation engineer and a SDET, you're probably talking somewhere in the region of $30,000 to $35,000 difference from a salary perspective. So it is very, very costly to bring in an SDET team. But the reality is that it's cost effective if you can reduce the amount of engineers you have to do tasks. So from a testing concept perspective, we touched on this the other day, but one of the biggest ones and one of the most modern ones we're seeing in software engineering now is TDD. So that's essentially where you're developing your test before the logic. So you write a kind of failing test, you make the test pass, and then you refactor as you go along. So you are continuously putting the tests ahead so that you're knowing when something's going to fail. So you're almost setting something up ready for failure, so that when it passes, you're all good to go. So it results in really, really clean and clear code, and you're only writing new code should the test fail. So you're avoiding duplications. The next one is BDD. So it's the process of collaborating and working between tech and non-tech to ensure that it meets the business needs. So BDD is all about following a structure. So it's all about context, when, and then. So context being, I don't know, what we'd expect the software to do is X, and then over time it will kind of build out, and then we're looking at what does the business think of this. So it's working very much for the business mindset rather than from the engineer mindset. So you're looking at, I don't know, what does our head of sales need within this software, not what does what do we think you should do as a software engineering team. So it's very much thinking from a business perspective, not necessarily from a tech perspective. Then the final one that I wanted to touch on, and we can go through stuff like white box and black box if people are very, very interested in it. So stick in the questions if you feel the desire to go through that stuff. So unit testing is testing code in very minuscule and micro levels. So you are breaking your code down into small units, and then you're testing as you go along. And again, we touched on this the other day, but essentially the reason you do that is that you can then find where the error is. If you're working in a waterfall methodology, you could go a week, maybe 2 weeks, depending on how long your sprints are, before finding out where the error is. Whereas if you're working with a unit testing methodology, what you would do is you'd write some code, you would then put it into a unit, you then test it. So maybe that's 2 hours worth of code. And then if it fails, you can go through what you've done previously and find where the error is, because you're not having to go through everything. So it's basically creating a series of tests on very small parts of code. Touching on mobile developers, pretty simple. We play around with our phones on a daily basis, but mobile development has become one of the most important types of development now, because I know that even on the hackajob perspective, we are looking at our own kind of mobile application, because that's where we spend our lives now. Your mobile is basically a mini computer. So I very rarely during the evening will go on my laptop at all. I'll use everything on my mobile, from getting food delivered to me, to booking in a taxi, to
Sorry,
renting a hotel.
you're still on unit testing slide.
How about now?
Yeah,
It's
there you
moved.
go.
Yeah, I was going to say it moved on my side. Thank you, mate. So that's why there is such importance behind mobile development nowadays, because if you aren't creating a app for your business and you are a consumer facing business, you're probably doing something wrong, because like I say, I'll book a hotel now on my mobile. I would never ever go to my laptop, and I own a laptop, pretty good laptop, and I just don't use it anymore. So I've learned my lesson not to buy nice laptops now. Yeah. So there's two different types of apps that you're likely to get. There's native and then there's hybrid. So a native application is written in the language native to that OS. So we'll go through a few more of them in a minute, but when I talk about the OS, just touching on it again from last week, what I'm talking about there is the operating system. So I'm talking about, are we talking about iOS, so on Apple, or are we talking about Android for Samsungs, etc., etc. So hybrid apps are built similar to how you build a web application. So they're written in stuff like HTML, CSS, JavaScript. But then if you remember from last week, we touched on stuff like React Native. So there's technologies that are in and around that kind of area that are hybrid. So JavaScript, C# can be used for hybrid applications. And then for the areas like Android and iOS, it tends to be stuff like Kotlin or Java for Android, and then Swift for iOS. And the reason that you might go with a hybrid application is that it's built across both sides. So you could have one team that are simply going with that effect. The reason that you might go with native is that from a intensive application perspective, it will perform better if you're doing it natively, because it's expecting to be on this platform. It's not having to, as the application loads, think about, am I on the right device or something like that. From a testing perspective, it means that you only need to have one team as well, because again, people are used to this, and because you are and because of the way that the applications are running, it becomes much quicker. So if you look at, I don't know, eBay, and it's running on iOS, from a load perspective, everything will load a lot quicker. And when you look at maybe a mobile application, if something is running a second or two longer than is needed, that can cost millions of dollars on a daily basis. So that's probably why you would do it from that side. The problem is, and we'll kind of go on to drawbacks, especially with iOS. iOS is it's a closed source application. So anyone that uses Android devices will know that, and I'm not promoting some of these applications, but because Android is open source, you can play around with stuff, and you can put in applications that the store may not approve of. So there's like loads of like piracy and stuff like that on Android devices. Whereas from an iOS side, it's closed source, so everything has to be approved by Apple. Therefore, it's much slower to get rollouts of new technology. So that's why over time we're seeing that stuff like Flutter is being used on iOS. The other drawback is that when you are working across two different teams, so let's say you have an Android team and an iOS team, effectively you have to make sure those teams are working in correlation, because you may want to release stuff in a quicker basis. But if you've got two different teams, they may not always align. So you might maybe have the iOS team that have created everything and it's ready to go, but the Android team are, which makes it quite difficult. And also you have to have two separate teams. When we I looked at New York, and I found this map really interesting. So on the right hand side, you'll see a lot of that is Manhattan and a lot of that is owned by iOS. And then the green is Android. So this is overlooking New York as a whole. And the further you get out of Manhattan, the more that it's Android facing. If you look at globally, so iOS tend to rule North America and Europe. And then when you look at towards Asia, South America and Africa, Android has more of a foothold. And that tends to be because of the almost exclusive feel to Apple devices. I will openly admit that I have Apple everything. And it's very, very costly. Whereas in a lot of these countries where maybe cost is more important, Android tends to win. And also when you go across to China, Android is huge out there. From a iOS perspective, so iOS is a operating system specifically developed for Apple, for anyone that didn't realize. So it was released originally in 2007. So makes me feel quite old because I remember getting the iPhone 3 back in the day. And there was a new version that was released at the start of or at the peak of COVID, which was 16.02, which was there to combat problems with facial recognition when wearing masks. So it's focusing less on the facial structure now and more on the eyes and features up top. Like I said, it's not open source. And then from a iOS perspective, from an iPad perspective, there's also an iPad OS. Which is specifically there. Within the US, iOS holds 45% of the market. So big on that side. From a iOS tech perspective, I've got a few ones on here. So Reality Kit, for example, is there mainly for a lot of the AR and VR perspective. But the one I probably would want to touch on the most is Swift for AI. So that is being used. Swift is a iOS language. It's mainly being used to update the coding within iOS devices. So historically, you would have had Objective-C was the main language for iOS, but you've transitioned on to Swift over time. From a Android perspective, so Android devices are used across a number of different suppliers or developers. So it was it's a mobile operating system based on modified version of Linux kernel, and it's open source. So like I kind of touched on earlier, you tend to see more experimental, let's say, apps on the App Store. It's open source. It's there for proactive testing. It's often seen as easy from adoption and launching perspective. So iOS is a lot, Android and Kotlin is a lot closer to Java. So what you tend to see is a lot more engineers that maybe are software engineers that move into the Android world. From a language perspective, you can use Java on Android. You can use Kotlin, C#, C++, JavaScript, and Corner. So it's a much more flexible iOS system for engineers. So it means that you see a lot more, like I say, move into that area. So why would you go with hybrid? I kind of touched on this earlier, but you've got a single code base which can be used across all platforms. So that means that you can kind of run it anywhere or set up anywhere. You can use the same development team, so much more cost effective than going with two different teams. And it also means that we've seen a lot of companies, especially from an enterprise perspective, utilize software engineers and move them into their mobile teams. So it means that you can set up teams and upscale and descale teams quite quickly, which makes it hugely advantageous if you are originally more of a web application company or you're primarily a web application company and then do some mobile, because you may not want to create an entire team if you are if you're just going to have the team there for like maintenance and testing of the applications. And kind of drawbacks, I've kind of gone through these a little bit, but the drawbacks is that they don't run quite as quick as other ones. They're not native, so it means that there's complexity when it comes to certain types, so financial companies or maybe if you're a mobile first business involved in delivery is when you're doing delivery, it obviously needs to run very, very quickly. So there's going to be hybrid drawbacks on that side. From a language perspective, mainly what you're going to see here is stuff like React Native, Flutter. Flutter's mainly actually used on iOS, but it is a hybrid language. Xamarin is based around C#, and then Iconic is the Ionic, shall I say, are the main ones that we see from those perspective. That's everything we were going to go through on this session. So we got through it about when I'd expect us to in half an hour. So please do start chucking your questions in Q&A. Like I said, obviously, if a lot of the questions are based on this, great. If not, then please chuck in anything that we've had during the week. So we hire in Kotlin and struggle to find engineers. What advice would you give? So I'll start first, Henry, and then if we go to you afterwards. So I kind of touched on this at the start. My recommendation would be to look at other JVM languages. So Java being the primary one. I also would say it depends on what you're looking to do with Kotlin. So are you using Kotlin from a web application perspective, or are you using it from a mobile application perspective? I think that if you are using it from a mobile application perspective, you probably want to look at similar languages that it can also be used on Android. So maybe look at C# or maybe look at Java. There's a well-known e-commerce business in Europe that we've worked with for about 7 years, and they tend to hire candidates from those enterprise software languages, and then they upskill them into mobile. So that's always quite a good route. Henry, would you add anything on that side?
I mean, there's some of the larger companies that have gone through massive rapid growth that are now scaling back. So your Ubers, Google's, Amazon's, they all have large teams in this. Obviously, it's going to cost you a lot more to get developers from there, but they're often good sort of grounds to look. But no, I'd really sort of echo yours. Either sort of cross training Java engineers or upskilling them is an incredibly useful way to do it, or looking at similar languages where people are happy to transition.
Cool, fine. We utilize DDD internally. What is it? So DDD is domain driven design. It's very, very similar to BDD actually. The DDD is quite confusing. There's about three or four different DDs at the end of stuff. So if you think about BDD is very business oriented, and it's thinking about it's building tests in the way that you would expect a business to run, or how a business would expect things to run. DDD is doing the same, but from a creating software perspective. So essentially, it's building software in the mindset of what the business would be looking for. So that's basically what it is. What locations are good for hiring mobile engineers? So this question, I suspect, is asking a similar thing to obviously what we've touched on in other sessions about good locations. So I would say Dallas is pretty good. Miami tends to have a lot of quite cool scale ups. So I'd say Miami's a good place to get people from. New York, if you can afford it, the San Franciscos of the world, because that's where a lot of the companies that are mobile first. I would always be thinking or going within the mindset of what businesses are a mobile first business, because they're going to be where you're going to get the best mobile engineers from in a lot of the time. So think about the apps that you are using on your phone on a daily basis, and then I would use that to headhunt candidates from, because they are going to be the hottest commodities on the market. They're also going to be the most expensive ones, but that's probably the approach I would give. So I would probably put a tracker on your favorite mobile companies, and then that's where I'd be going for it. So I think that as we become more fluid in localities across the US, you probably don't want to be too stuck on a location. I'm seeing a lot of the companies move to the Carolinas now. So yeah, I would say probably that. Henry, would you add anything on that?
I think you covered pretty much everything there. Location, obviously, remote first is king for a lot of developers. But if you want obviously office location, then yeah, you've covered off everything.
Awesome. We see a lot of contractors on the market. Why would this be the case in mobile? So this one's specifically for mobile. So mobile is a very contractor-based market. The reason for that is that oftentimes, if you aren't a mobile first business, what you would do is you would write your application, and then you probably would move on. And anyone that's left in that team at that point will be there simply to do any small updates, any bug fixing, etc. So they're there more from a maintenance perspective. And obviously we touched on in a lot of the previous slides when we were looking at it's going to take me a second to get through them, man. When we were looking at the drawbacks, fixing and monitoring of tickets, that's what, if you want a mobile first business, that's probably what your mobile team are doing. So therefore you probably would bring in contractors to do it and set up the application, and then have people that are there more from a bug fixing perspective. Also, because of the fact that the contract game is where you can earn very, very good money, obviously people going to follow that route. And then finally, mobile is probably one of the quickest developing marketplaces out there, and technology changes on a almost monthly basis. So if I'm a mobile developer and I want to learn new technology, the best way to do so is to move around organizations and work on new projects. You don't tend to spend as much time on a project if you're doing mobile than you would if you're doing web applications. So I'd probably say that's the three reasons: amount of money you could earn, whether they're a mobile first business, and also depth of technology that's changing on a monthly basis. So therefore, do I want to stay in an organization where I'm not going to really excel?
Yeah.
Again, Henry, anything you left?
I was going to say, yeah, if you are going with mobile devs who've worked on a lot of applications before, something to consider for companies as well is technical debt. So making sure that your team understands what's being built by contractors is really key. You don't want them coming in building something, then it taking you twice as long to unpick what they built and being able to sort of upgrade it or rewrite it in the future if something goes wrong.
Awesome. We're struggling to match our competitors for salary due to remote working. What would you recommend? Remote working? No. So I think it really depends on what you're looking for, and I think it probably depends on where you're located. If you're located, I don't know, in Utah, it's probably much harder to find engineers than it is in San Francisco. So therefore, you probably can, if you're in San Francisco, you probably can look at someone in the office because the supply is a lot more. I would always go back to classic economics, like supply and demand. Where's the equilibrium in it? And the further you are away from the supply of the market, the more you have to flex on things. So I'd say that if you're struggling to match on salary, think about what are you asking for. Is there any flexibility that you can look at? And we've obviously touched on this several times during these sessions, but I'd also consider, could you bring in someone and maybe upskill them over time? Appreciate that's not always the case when you're bringing in staff engineers, but if you can bring in someone who maybe doesn't know a language or maybe doesn't know a framework, and you can upskill them, the reality is you'll keep these people longer. You don't want to bring in someone who already knows everything because they'll leave quite quickly afterwards. So I would look at what is the supply in your area, what flexibility can you offer? So if you can't do remote working, can you offer a model where people come into the office maybe once a quarter or once a month? And if you can't, I'd be asking the questions about why can't you? There are certain organizations that we work with, such as defense organizations or biomedical, where you need to be on site. But I think for a lot of organizations, if I'm an engineer, then there's not really huge amounts of reason why I couldn't work remotely. The only one that I often hear from organizations is, why should our engineers be able to work remotely when none of our sales staff can or none of our merchandising staff can? But I never think that's a strong enough argument, because you can find a lot more salespeople. And I'm a salesperson, so this hurts me to say. It's easier to find a salesperson than it is to find an engineer. So I think that you really need to think about what supplies out there.
Yeah, absolutely. I think it's, like echoing what you said at the start, I think it's really understanding your internal requirements, and then so you balancing that to your cost or what you're happy to spend, and then being able to flex on that, whether it's the experience level or like does up training or upskilling people, or bringing in 3 juniors for 1 senior, and then upskilling all of those your longevity and obviously your intrinsic knowledge of the company is going to grow in your obviously your talent base then.
Yeah, awesome. What are we seeing in the market when it comes to remote working? So I'll take this one because I obviously oversee much of the US. So I think what we're seeing with a lot of organizations is they're more time zone remote than they are locality. So I think when we first launched in May, a lot of the companies we were working with would say, okay, we want people within the tri-state area or something like that. Whereas what we're seeing over time now is actually, and it's surprising how quickly it's developing, what we're seeing is that a lot of the companies we're working with now say that they need to be maybe on the East Coast, or they need to be on the West Coast, or Central Time or something like that. So we're seeing that if people are working remotely, often they need to be within a certain time zone, especially in stuff like DevOps, because you need people that are on call at certain times of the day. So I think it's more important for certain markets than others. I think I'm surprised how little we've seen changes from a salary perspective. I think when COVID first started and people moved more to remote working, I expected that the cost for an engineer would probably go down, but it's not. If anything, we're seeing it go up. I think in the last 2 years, we've seen on our platform salaries increase by about 19%, which is exactly what is happening in the market as well. So it's not even just refined to hackajob, but I think that engineers are aware that as the world becomes more remote, you also need more engineers to deal with that. So therefore, they can then ask for more money, and then at some point, potentially the bubble will burst. But I think we're seeing salaries increase at an exponential rate. Is there any, Henry, anything you'd add? I had one more thought, but it's bypassed my mind at the moment.
No, I was going to say it's a pretty common problem with everything going remote, not just developer jobs, but obviously the top 10% of sort of what you might see as the most attractive companies to join, sort of like 80-90% of developers sort of actually benchmark themselves against what they can offer. So it leaves everyone else really fighting for a much smaller share of the marketplace if you're not on that front foot. So it is a really difficult problem to solve, but it's obviously an industry standard problem. So it's about being as flexible as possible within obviously your own budget requirements and what you can actually offer on a practicality level.
Yeah. And sorry, that was the final point. So I think what we're seeing from a lot of companies at the moment when they look at remote is they are looking at where are people based when they consider the salaries for someone. So they have benchmarking on what would we offer in X state and what would we offer in Y state. So I think probably look into that a little bit. So there's certain locations that I'm seeing salaries a lot less. So I think New York, Massachusetts, Texas tend to, and California tend to be the more expensive ones. Whereas in the Carolinas, I see salaries tend to be a lot less. Down in Florida, except for the Miami area, salaries tend to be a lot less. So if you are able to look remotely and you are quite stringent on what you can offer from a salary perspective, maybe look at some of those other locations and benchmark based on states might be something to look at. Someone's asked a question which we didn't go through today. So you mentioned you were going to touch on databases. Can you discuss the difference between NoSQL and relational databases? So NoSQL is it is the same as non-relational databases. So I think we touched on this briefly the other day, but not a non-relational database is basically a database where stuff isn't stored in columns and rows. So it's stored in or scattered around within the database. And the reason that databases are set up that way is that you can pull data in isolation. So you could say, right, okay, I want to pull data from the 7th of October 2022. I want to pull all the data from that, and you could just pull that one subset of data if that's stored together. If they are in a relational database, that means it's very similar to the way I always think about it, it's an Excel spreadsheet. So everything is in a column and row, And when you were to pull a piece of data, you'd have to pull the entire column or the entire row. So it might be set up in like college. So you might, if it's a relational database, you might want to pull all of the students that were in that graduated in 2021, and you could pull that entire column. But the problem is, if you want to pull one particular student, you're probably better off having it in a non-relational database, because you can pull that single student, not the entire row or column. And the reason that matters is it's all well and good if you're only pulling a few rows and columns, but if there's, let's say, 100,000 people that you're pulling records on, that could take you a long time to query all that data. So companies tend to have relational and non-relational databases. And the way to know if it's a relational or non-relational database is if it's got SQL in it. So SQL Server, MySQL, it tends to be a relational database. If it's got DB on the end of it, so Redis.db, Couch.db, Mongo.db, they are non-relational databases. That's how it's the easiest way to define between the two.
Yeah, I always remember SQL as structured fields in defined columns.
Exactly.
And NoSQL is just a jumbled mess altogether where you got to plow through everything.
Exactly. Any other questions? So there were only 7 questions in the Q&A. So any other questions that people have got? I'll give it a minute or two. Oh, you guys have been nice to me today. I was expecting there to be loads of questions on DevOps and front end stuff I'd done a few days ago and hadn't really thought about too much. So you've been nice to me.
Well, I've got one for you guys. Do you know what the most popular out of obviously the modern frameworks, the modern languages that we talked about earlier, the most popular or most in demand one is in New York at the moment, between sort of Kotlin, Go, and Scala?
So it depends on what you're looking at it from. If you're looking at it from a purely software engineering perspective, so application, it definitely would be Go. And I think that's the reason for that is that it's easier transitional language. Kotlin, I'm tending to see go more to mobile. There's not many companies I can think of who are a Kotlin first web application company. And then Scala, I'm seeing move more towards data engineering. So again, unless you're a very data heavy organization, you probably aren't using Scala for web. So I would say the Golang's the one at the moment. I think Rust will probably be the one that will take over quite quickly. And really good point from you there. I think that because Rust, I suspect that people won't even know what Rust is at the moment. So Rust is very similar to these languages, but the problem is when they're a functional language, it takes a while for them to catch up. So you tend to see them in stuff like GitLab, Bitbucket, GitHub, and on personal projects for a long time before they get into the public domain. And the reason behind that is that if I am, let's say, Capital One, and I decide that I want to use Golang, it's going to take me a lot of years to update all our code base to the point where we're actually using Golang as our main language. So it tends to take a long time for these to catch up. So I would say, depends what you're looking for. If you're looking mobile, Kotlin's probably the one that we see the most. If you're looking at a data heavy organization, probably Scala, and then web application, probably Go. Good question, Henry. Cool. Right, I'm going to call time on this. If people want to reach out to me on LinkedIn or reach out to me on email or Henry, please do reach out. More than happy to answer stuff. We'll be running these sessions again probably in about 6 months' time. So if you've enjoyed these sessions and maybe there's an area we've missed out, please do reach out to me directly and we can include it in that. If you want to just brush up on anything that we haven't covered, please do again reach out to me and I can just answer any direct questions you've got. But thank you so much for everyone that's attended and including those that have attended every session. If you've attended every session, you will be getting an invite to our wine tasting that we'll be doing in the near future. So look out for that. But yeah, everyone have a lovely day. Thank you very much for attending.
Cheers, everyone.